Today's topic is what's called the ambiguous case. And I'm no wordsmith, but as far as I understand, ambiguous just means given the info that we know, we are not sure which result is the one that's happening, where it's unsure, unclear. So I told you at the end of the last video, I remember because I just said it, be careful when finding angles with the law of sines, and this ambiguous case is the reason why. So just take a look, sketch these two triangles in your notes, take a look at them and see if you can't realize why this is a problem, okay? Given 31 degrees, 10 and 6, which is side-side angle, or angle side-side if you prefer, given that info, it could be either one of these setups. Would you agree? And if I say, hey, what's x? And x is this side or this side. X is very different in the two different cases. What's the angle opposite the 10? Let's call it y. Well, two very different angles. What is the angle across from x? Two very different values. So in different circumstances, one of these two will be the right answer. And in other circumstances, you have to say, well, there's two possibilities. If they just say, and sometimes there might not even be any possibilities given the info. So just to kind of discover why, if you are given angle side-side, let's say you're given one side down here, and then you're given the other side over here, and then the angle, not the angle between those two sides, but the angle over here. So if I know that angle, and I know this side and this side, a couple different things can happen. Like the example I have up there, it might be that there's two possibilities where that same length kind of fits there and creates two different triangles. It might be that there's only one possibility, in which case the sides would kind of look like, well, there's a couple ways there could just be one. It might be that that one just barely squeezes into place, and if you were to rotate it around, it would just touch that line once. Or it might be long enough to where, let's see, if it were a triangle that kind of looked like this, and that was the third side, if you try to swing that one around and make the other option, it misses the end of this line over here. So there's only one option that way. Or it might be that there is no such triangle if you have a short other side. So if the side is only that long, it doesn't matter which angle you swing it around, you're never going to hit that dashed line. And that dashed line can't move because we were given that angle. So that's a lot of different options. Again, that's why it's called ambiguous. If you are given side, side, angle. Now, lucky for you, the math is going to work itself out, and it's going to tell you which one you have just based on the given info. You're not going to have to, check and see which one of all these it is. Let's work with the example that we have right here. All right, so if I tell you that 31 is the angle and the 6 and the 10. So I've got a 6 and a 10 and a non-included angle of 31. You are going to be safe using the law of cosines. All right. What do I know about this triangle law of cosines? Well, I know that the 6 corresponds to the 31, meaning 6 squared equals 10 squared plus x squared minus 2 times 10 times x times the cosine of 31. All right, the 6 corresponds to the 31, so the 6 is the first thing I write. The 31 is the last thing I write. Now, you're going to get a quadratic equation if you work this out. That quadratic equation should reveal a lot about which one of the cases we have, or it'll tell us that there are two possibilities. All right, so 36 equals 100 plus x squared minus, let's see, I've got 2 times 10 times cosine of 31. 2 times 10 times cosine of 31 is 17.1433. I don't want to round that number off too much, but I don't need all those decimal places. I'm going to be close enough. So here's my quadratic equation. You always make a quadratic equation equal 0. And then I've got 100, and I'm going to bring that 36 over. I'm going to be left with 64. Okay, so quadratic equation. Remember when we talked about quadratics? Sometimes they have one answer, sometimes they have two, sometimes they have none. In this case, we might have two that are good, meaning it's like the picture that we see, two different values of x, or we might have two where one of them's negative, and in that case, you only have one true answer. So we'll just kind of see the nature of our answers. If we get imaginaries here, if we have a square root under our negative, that's telling us that it looks like this, where I don't have any triangles, no matter which way I swing that other side. All right, so let's use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, 64, all over 2a. All right, so I'm going to pause a moment, get that in my calculator, be right back. Okay, so I've entered in the quadratic formula. This is the plus version. So if I use the plus sign, I get 11.65. And if I use the negative version, I'm going to hit second enter and bring all that back and just go back and change my plus to a minus. Then I get 5.49. So I'm asking the law of cosines. Dear law of cosines, will you please tell me the length of that other side? And the law of cosines, because I got two real positive answers for this quadratic equation, tells me it could be 11.6 or it could be about 5.5. Well, look here. How long is x? It could be 11.6 and it could be about 5.5. So what I was saying about the law of cosines telling you which one it's going to be, because I got these two positive numbers, it's telling me, hey, this is the case where there are two possibilities. If all you're going to tell me is 6, 10, and 31 degrees, then there are two different ways it could go. Now, once you've gotten to this point, you break into two different worlds. One where it's 5.5, in which case we find the y and the z if x is 5.5. And then in the other one, we find y and z if x is 11.6. So if you're solving the triangle, you're going to have two different triangles. So you're going to have three answers, x, y, and z, two different times each. Now, here's where the danger comes in. What if we are trying to figure out angles with the law of sines? Now, that was what I said was the danger earlier. So how do you eliminate that danger? Well, here's one. You can always use the law of cosines. The law of cosines will not let you down. The law of sines might let you down. Let's just say I'm telling you side y is 10, and let's see, I'm going to tell you that, let's see, I'm going to give you, wait just a second. Let me start that question over. Let's say that I give you this triangle over here as the setup. And I say, okay, what is angle y? If you use the law of sines to get angles, so find angle y, then I would set up my law of sines that said sine of 31 degrees over y, over 6 equals sine of y over 10. All right, 31 goes to 6, y goes to 10. All right, so I'm going to get out my calculator and solve this proportion. I'm going to do sine of 31 times 10 divided by 6. Now sine y equals this number, so I need to inverse sine that number, and I get 59.1 degrees. All right, so it looks like it worked out. Is y 59.1? Yeah, it makes sense. It's not completely wrong. Okay, so in that case, it worked out fine. Use the law of sines to get an angle. Sometimes you're going to be okay. But let's use the law of sines given this triangle over here. What if I gave you that triangle? We don't know that side at this point. What if you were given this triangle on the left and it said, find angle y? Well, law of sines, sine 31 over 6 equals sine y over 10. Y is across from 10, 31 is across from 6. Law of sines. It should work, right? We learned it last class, and it's called a law, so it should apply. Well, look at my setup. These two things are exactly the same. I'm going to do the exact same thing in my calculator. I'm going to do sine of 31 times 10 divided by 6. I'm going to inverse sine that, and I'm going to get y equals 59.1 degrees. So do you think that this is 59.1 degrees? I do not think that it is, because it looks clearly to me to be an obtuse angle, and I could go on further to show that it's not 59.1 degrees. It's actually 180 minus 59.1 degrees. But the law of sines doesn't tell me that. So here are that's your problem, and here is your solution. If you are given a picture, then they are telling you which one of the two. And you need to look at your answer and see if it's reasonable. If y makes sense as 59.1, if I'm given this picture over here, I see 59.1, I'm like, yeah, that makes sense, it worked. If you're given a picture and it doesn't make sense, like this, because y is a big angle, looks like well over 100 degrees, and I get 59.1, then that's a problem. So, the law of sines is faster and it's easier and it's easy to remember, but if you use it to find angles, you might be getting the supplement of your true angle, 180 minus your true angle. All right, and there's really nothing we can do about it except use the law of cosines when finding angles, or checking to make sure that your angle makes sense. All right, so this will come up in different scenarios. If they just give you 6, 10, 31, then it's your job to say, well, it could be the one on the left, it could be the one on the right. Let me solve both. If they give you a picture, then you're going to need to decide which one is which. And if you use the law of sines, it can be tricky. All right, so remember that. Here's the warning from last video, and here's the reason why. That is definitely not 59 degrees. All right, so this has been the ambiguous case, SSA. Watch out for it. It can be your friend or your worst enemy. Young out.